So first of all, well, I'll put the bolt through here. I'll put this conversion piece on, put a nut on here, and there's one of these types of washers, an odd type washer. I'll put some details on here. Now there are wedge shaped ones. Can I get this in focus? Sorry about the lighting in here. But that's basically the same both sides, right? It's got ridges on both sides. There we are, that's a bit better I think. It's slightly curved. So put like one of those on here between the board and the cutting blade. Now be very careful with this cutting blade. It's extremely sharp. And then put another Nord washer and another bolt on here. You see that nut there? So this is a cutting blade. Put some details here. And as you see, I've screwed this sort of nut here just inside the edge here, about 3mm, maybe 4mm, to allow for the thickness of the washer and a little bit of gap when I screw this in together. Yeah, and there's two. So as I say, these are not wedge shaped washers. They are wedge shaped types, but I've just got these ones. When you've got this on, make sure that this cutting blade is in the centre, maybe slightly over to the right, because as you tighten this nut up, it's probably going to move a bit left a little bit, if you get me in this case, looking at this the way we are. So I want this in the centre of the gap. Just turn it by hand to make sure it's not rubbing on anything. Pop the other bearing on. There's already one bearing in this side. Here's some details about the bearings. There's a big like ball race bearing, I believe. And there's a couple of nuts go on here, which tighten up against each other with one of these Nord locking washers between. Okay. We'll tighten this big nut up so that in a way you've got two nuts going against each other, with, but in this case it's got these Nord type washer things in, which I showed you. Okay, that will stop that turning, or should do. Tighten this up first before you put the other side on, because it's very hard to get in here. Just go specialist spanner sort of thing. So this is what I call a mole wrench, a hand vise. This is a very old one. You can adjust this to open and close the jaws. Called mole. Can we see that? We might be able to see that. M-O-L-E stamped on it. That's the make. But there are other makes very similar, or any spanner that'll grip this nut here. Quite a big nut. Bolt there. Put all the details here. Put some of the details here. So here's a bit of a look round. Two nuts tightened against each other with one of these single type Nord locking type washers in. These are not the wedge shaped Nord lockers, Nord washers, sorry. Make sure it can still turn freely. My hand here. As you see, be careful of those blades. They are very, very, very sharp indeed. See, that turns freely. This part here is what I call a wear plate. It's easily removed. If it wears down on the top, just pin it 100% to save you replacing all of it. That should wear down quicker. Here's a smallish hopper. I bolt this in with these 3mm countersunk bolts here. I'll show you that just now. I'm doing this one-handed, so I'm slipping about here all over and one thing another. I'll show you just now. There you are. There's a bolts bolted in, countersunk. The other bolts there are 6mm just on a bit of old shelving I've got here, wooden shelving. Make sure it can still turn freely. Yes, no problems there. This is like a safety cover, just to protect the blades and protect your fingers a bit. See, sharp blades warning on it. So here's a bit of a look round. And I'm using this electric, like battery powered drill part of. It's fallen to bits a bit. I've took it apart and I've clamped it in here, as you see. This does have a torque control on. You can slide it up and down on these slots. And it does turn anti-clockwise. Normally it turns clockwise looking from the back, but I've had to rewire it back to front, so positive goes to negative, negative goes to positive, so that will turn anti-clockwise, which is the direction I want to go. This chuck has certainly seen a lot better days. In here there's like a 8mm nut, 8mm bolt, and then there's a big bolt head of the 22mm bolt in the other side. This 8mm bolt can move about a little bit, so that it's got a bit of free play there. Okay, so by the way, I've got this on like reverse polarity, the wires, because normally the drill turns this way, but I want it to turn like this way, which is, if I turn it around this way, it's sort of anti-clockwise. So as I say, that's a bolt going in there, and the head sticking in this part, and the head of the big bolt here, which has the cutting blade on. Is thingy. I'll just show you that this is empty, this ball. So I ain't going to fake this. You get that stabilised. I've just got propped up on a chair at the moment. Let me move back a little bit, a bit more in. So I think this is a bit better angle. I need to move this over a bit. I tried using one of these. This is like a worm gear in here, and it's got some cogwheels. So there's the details. 100 RPM. These are M3s, these bolts in here. So I tried using this and it wouldn't even turn like a belt thing, not enough power. There was enough power when I was turning this with a belt as follows, but as I say, this whole part at the front here was bending inwards, so it was like loosening the belt because it was moving inwards towards this, the pulley that was on here, and it would just skip over the teeth of the belt. And what I found also is that the belt, in my opinion, takes quite a bit of the torque out, the power of the motor. This is on full power. Let's get turned on. I'll take this is like just a safety cover to protect it from, because these blades are very sharp. I'm using, just a second. This is what I'm using to power it, 30 volt. I think is it 5 amp? There's a model number, can you see that? So I have to get this plugged in before I turn it on. Right, I've propped up this power supply a bit. Now it's wise to turn down the voltage, probably the ampage on these, before you use any inductive load. Turn it on. I'll turn up the voltage. Put the voltage, and that should turn the amps up as well. See, that's just starting to turn there now. That's saying only 2 volts. This is 12, well, probably 18 volt this motor. It's so about 2 amps according by this. Call it 4 volts there, and it's turning. I let go a bit because I want to make sure it's okay. This nut head here, that's in here, is a little bit loose, so it's got a bit of flexibility to a certain extent. Right, let's shot a bit of plastic on. I'm going to shot this bit of plastic on here. See, it's just got infill. I'm scared stiff about doing this. I've got this to poke it with. No, it's jammed there, but we aren't on the voltage that we should have, so to speak. Now I think the blades are slipping there. Oh no. No, the nut in here is slipping. It's not tight enough. I find it very hard to tighten this up actually. I'll come back when I've done that. This whole drill part has fallen to bits. It's very loose, this ring round here. You can even see the chuck parts coming out there. I've tried tightening it up a bit by hand. Let's see if that's any better. Turn the volume, voltage down. You can get on. The amps is on full there. Sounds like it's trying to cut it, but not much impact there. Bit of roughness, that's all I've got there. That took a little bit of a chunk out. When I'm like pressing on it, a bit more pressure. This bolt in here, I should say a bolt, is still slipping. Yeah, that is definitely slipping there. Likewise, turn it off, turn the voltage down before you turn it off. So I'll show you that. Not going as well as what I thought, well hoped. The problem is this chuck keeps slipping all the time, and it doesn't have a chuck key. I think it is one that you're supposed to tighten by hand. I'll just show you. You might see it in my, yes, put my light on. You see there, you can actually see the things of the chuck. Hopefully You can see those coming down there. Those are like the teeth of the chuck there. I think this thing is supposed to be right up and pushing against these teeth actually, sort of this chuck wheel. Now it is possible to remove these chucks. There's a bolt in left hand thread right in the middle, and you have to unscrew that left hand, and then you have to unscrew the chuck separately, and that would, you know, get rid of the problem with the chuck here. That's something I'm going to have to look at, because I did try removing this chuck and I couldn't get that bolt undone actually. Had a brief try. I'm going to try tightening this up again. Right, I've tried tightening the chuck as tight as I can. By the way, there is a torque thing on here, and I've got set to maximum, which is like a shape of a drill bit on here. Make sure we get enough torque out of it, like so, otherwise it sort of has a slipping clutch. Now I looked up about tightening these, and it said tighten it until you hear a click. No click head, or a few clicks and stuff like this. Obviously unplug it before you turn it back down. Put the amps on full, gradually turn the voltage up. That's coarse over the right hand side, I think. Right, let's see what happens now. Going a bit fast for my liking. I'm going to try dropping this on, like one of the pulleys I've tried earlier. So it's got tooth marks in, but it would slip certainly on a smaller pulley. So I'll show you this. Not working well at all, really. I'm thinking is almost that the blade needs to sort of almost come possibly down here this way, to almost jam in like an edge down there. These are for cutting metal, these cutting discs, so it's not the cutting disc. It's either the height of the cutting disc, the blades sticking out there, or something like that. I reckon they're sticking out about 5-6 millimeters. You see that other part just bounced out. I've got some support here. Going by this is 5 volts there. If I try to drop it on, it just bounces out. Do this edge, show you. to have to think about this. What I've read online is that you tighten this ring, which is very loose on this one. Well, you hold that ring there, and then you tighten the chuck until you hear a click, or two, I think it is. And you tighten it the other way, so to speak, and that will tighten the as this turned, this whole motor's turned, I think, because that was at the top, that, even though this is very tight on here. So like the back torque of this, it's just gripping. These just grip these, like there's two clips here which of these 3mm Allen bolts, so would squeeze and grip it. That's all that's really holding it in. Just thinking there, if I had a deeper hopper, then if it did throw the parts out, it would catch against the edge of the hopper and fall back in, basically. That is part of a solution, maybe, possibly here. But I think it's going like there. I'm having to put quite a bit of pressure on. Let me try doing quite light pressure on. That's what I'll try doing. Pushing it quite lightly, I think. We plugged in. Yep. Come on. Turn up the amps full. But on 5 volts, I find 5 volts is probably enough actually. I'll have to be more careful with light pressure actually. It's going up to 5 amps there, you can see. Not getting too hot. When it gets jammed there, it's going up to 5 amps. It's getting through to the infill there. I think there's at least 2 layers, if not 3 layers on the sort of this before the infill. Actually, when it does that, I was hoping that there'd be enough power to really whip round that. Let's try turning the voltage up. So we're on 5 amps, we're getting no volts because we're turning the voltage back down. So that's 12.8. I don't think you can see that, but it's 12.8. Leaving no 3 amps there. think that's tripped the power supply unit there. The motor's, well, only very, very lukewarm, but slightly warm. It's not hot at all. So I'm going to let it cool down a bit. Make sure it's cooled down. But this shredder idea is basically, it's not working very well, is it? Obviously, you could have a more powerful motor, more of these blades spaced apart, basically. I reckon. These like cutting things here to put some details here. So I'll try and show you the damage done there. That's when I was using a bit of lightish pressure. Was the disc coming round like that. And this is when the blade's been like whacking into it, like almost like this, so to speak. So it's not very successful, really. So if you did use more blades, you'd have to have a different design from this, but you'd need a lot more powerful motor, because at the moment it's all that torque of the motor is going just onto the one blade here, one cutting sort of blade there. Might be on 6 there, aren't we? 6 is at the top. Let's try this again. Let's see if it comes on. Make sure that voltage turned on. Coming on there. I think about 5 volts is. I think if I leave it on that, it's going to cut out the power supply. There's safety things on this power supply. Turn it down and then turn it off. So it does jam. So there's not enough power there to rip through this when it's set to this height. There is what I call a wear plate in here. The idea behind the wear plate is that this plate sort of thing gets worn and you can generally easily replace it. Obviously you could sort of make that deeper, that wear plate, and that would in a way only expose like the very tip of the blades. That's one idea. I'm going to try this piece, which is, as you see, about 1 millimetre thick, say, maybe slightly more. Have to be very careful here. So you can see what's done to that in that length of time there on this thinner, much thinner piece. As I say, these are for cutting metal, so it should easily cut plastic. I think the general idea there when it's cut metal is just shave, you know, a few thou off at a time sort of thing. Here I'm trying to cut, you know, a millimetre at a time almost. Let's try this a bit more. Turn that down because it's, yes, this has moved. That 6 was at the top and that's moved round. So this is slipping, this mortar in here. There are some lumps on this plastic part here that I could put a peg or something on to stop it turning. But that seemed to be slowing down there, so I'll turn it off a bit. Can't feel any. The mortar is very slightly warm. It's not hot or anything like that, it's just slightly warm. Trouble is there, obviously if this is twisting this mortar, it's going to twist these wires. You can probably see that they're starting to twist a bit here already, getting caught up. Just a reminder that, so far as I'm aware, these are what they call planetary gear system in. So the motor's turning quite fast, but the chuck is turning slower in relation to the motor, but then we're getting a lot more torque out of it. So this motor, although pretty powerful to do this cutting, is not powerful enough to turn this blade. That's what I figure there. And to actually, once these like spikes on the blade get caught on here, that's it, it jams and the ampage shoots up basically. So that's turned down, let's get back on. I'm not sure if you can see that. It's about 5 volts, call it 3 amps there. See, once it gets stuck there, it goes to 5 amps, and it's only on about 1 volt there, just under. I'll turn this down. Don't want to turn the voltage up too much. And then turn it off. So the motor is jamming there. Let me try to turn this. Can I turn this by hand at all? Nope. Not without getting a spanner on it or something. You see the churn it's been doing, yeah. Right. Just zoom in on those blades a bit. You see the blades there. Let me make sure this is unplugged. Don't want to starting up while I'm mucking about with it. You see the blades here. Once it see the blade jams, the edge of the blade sort of jams against the edge of the plastic, and then the motor's not powerful enough to actually force it through there. So we're going to need quite a lot more powerful motor than this one I've got here. Right, I'm going to leave it at that. I'll just show you one final look inside this tube thing here. Just take this power supply out of it. There's a bit of loose on top here. Again, very fine. Can we get in focus there? So you see how fine it is. It's almost about as fine as I would say coarse-ish washing powder. That's what I'm trying to think of, although it's obviously harder than washing powder. That's on top. And inside I'll just get this into the corner here. So I think the only possible way of getting this working here is to get a lot more powerful motor than this one. This like drill unit I've got here from inside electric drill, battery operated drill. That's something I'm going to have to think about, and then there's money as well. On a very tight budget here. I'm going to leave it at that. I think the basic idea seems to be not too bad, except that, as I say, the edge of the blade there. This is my plastic shredder for shredding plastic. This is the first real test I'm going to do of it. This is a shredder here. It's got like a milling for a CNC machine cutting blade in here. I'll put some more details here. So that is the cutting blade I've got in there. That's locked on this. There's a 22mm bolt in here going through, because that is the size of the hole inside. I've got this plate that can go over there just to protect fingers, because it is quite sharp. Well, it's very sharp really, the blades. There's some adjustment on these slots if you can see them. I've got a old drill, I think it is. I've had a long time and it's given up the ghost, so to speak. Actually, I need to turn this, don't I? Because it's got a torque thing on there. These have gear reductions in. I believe they have Planetary gears in. There's like a gearbox here, and the electric motor is clamped in here with these clamps here, but your electric motor might be different. Obviously a cogwheel, timing belt, and there's some gear reduction there a little bit, because it's going from smaller to bigger. I'm working this off to 5 volts off this PSU power supply here, ATX. I did try pumping it through this voltage buck boost converter, about 12 volts, but it started sparking and it gave off smoke, and I think I've burnt out the 12 volt rail on this, because so far as I know the 12 volt isn't working on this, but the 5 volt is alright. I'll turn it on now. I've got some old plastic here of previous prints, iterations that haven't come out well, you know, the wrong size or need modification. This is the first time I'm going to use this, so I don't know what, well, I mean, I have used it manually. Now there's going to be quite a bit of noise when I start it up, and probably even more noise when I put plastic on, so we'll have to watch out for that too. But try and watch for any plastic coming down here. I'll try and move the camera down when I get it going. Let me get a bit. So this is the first piece I'm going to try. I think this is 30% infill. I'll snap that off. Can we see? Yeah, well, we can see there. Can you see that? That's 30% infill, so it's not 100% strong. Right, I'm going to start it up now. As I said, there'll be an awful lot of noise, so watch your ears here. And I'm just going to drop this on. No, let's see. So it's slipping on this drive here, the belt. The trouble is, the tighter I turn this, the more torque it needs off the motor. I'm going to tighten this. That's stuck in there. It hasn't cut it at all. I don't think it's even. Hasn't even left a mark on it. So I'll just try this again. I'm going to try putting this edge down this time. Again, watch out for your ears. Now, it's definitely slipping far too much on this timing belt here. So I'll tighten this up and then I'll come back. Right, I've tightened it up by sliding this whole thing across. See, there's slots in this plastic here. There's a bit of slots in the back of down here. I might make them bigger actually. About 5mm, say. Let's turn it on and see if it does it without any plastic on it first. So watch out for your ears. It might not even turn. Yes, it does. It is turning, when we're looking at it here, it's turning clockwise. It might look like it's turning anti-clockwise because of the strobing of the frame rate of the camera. Right, I'm going to try this bit again. 5 volts. This small cog is definitely slipping. It's biting there, but it's not really cutting anything off. That small cog there, that small cog wheel is slipping. So what I'm thinking of doing is printing out a bigger one about the same diameter as this one. This is just a spanner I made to tighten up the nuts. Didn't work. Well, this was the wrong size. Actually, I did it wrong, so that one's shredding up if I can get the shredder working. I think the theory's alright. So I'll print out a bigger disc here. Might have to move all this over a bit because a bigger disc will tighten this belt up even more, so to speak. And we'll try again. I'll just try and show you from the top. Have I got this light on? No, I haven't. Helps to put lights on. So it's got these slots, as I say here. I've run out of bolts, so I haven't got all the bolts in. Here's the old electric drill in this bracket, and this has got 3mm screws on in this case to grip these things, and that's pretty sturdy. It's just, I think it's just this tooth cog here that's the problem. Maybe it's just too small, so I'll try same diameter as this one. Okay, and then I'll come back. I'm putting it on this ball so we can hopefully see partly see and catch any bits falling down. This is a bit temporary. This is just a bit of like work top about 15mm thick. I'll show you underneath. It's all slot in, cut in with a jigsaw, a bit rough, but that'll do. The heads are sunk in there of the balls. Let's put that safety cover back on, so that helps protect fingers from getting cut and stops anything falling on sharp blades, and they're not kidding when they say sharp blades. Right, I'll print out that one bigger. 5 volts, whatever amperage this is, about 3 amps I think, 2 maybe, ATX, old ATX. Okay, I've just put on this bigger, like timing belt pulley here, about the same size as that. It's got a different bolt inside. This is the one I used previously, and it's not giving enough grip, even though the teeth in it, you see the sort of teeth I've got in it are quite deep. I don't think there's any problems there, but like having a bigger one here, it's got more teeth as it goes round. Now this is well, I did give it a brief try a few minutes ago. Now watch out for the noise here. Right, I'll turn it on. Can we see, is everything in? Might look like it's going backwards because of the slowing of the frame rate of the camera, but it is turning sort of clockwise. It's turning this way. This drill is reverse powered. It's only on 5 volts here. I'll let that run a bit because this is like the first time I've tried this. Right, I'm going to put this bit of plastic, old plastic sort. This is actually the motor stand, the first iteration of the motor stand I did. I'm going to drop this in here in the hopper and see what happens. And I've got this sort of plastic spanner that I made for tightening up the nuts in here. This is one that just a second please. Right, so what's happened there is this is an old drill bit, and it has a torque setting on, and it was set to quite weak. I've tightened that up. Now this bolt in the chuck is slipping. There's a bolt in the chuck there, a nut to tighten this up. This is like just a bolt head going in there, hexagon bolt type thing to grip. So what I'm going to do, I'm going to tighten up the chuck now. Let's have a look at that. No marks on there. Can't see any cutting marks on there. This is very sharp, this blade. Right, so I'll tighten up that chuck next. Actually, I've just been looking at the chuck and I can see the teeth of the chuck are coming out the back here. This has seen better days, this drill bit, old drill bit. Like drill, electric drill, battery powered. This is going off 5 volts, reverse polarity, because normally drill will go this way, but these are turning this direction. You could swap this blade direction round. Right, I'm going to try again. I've turned up the torque to full. Watch out for noise. I think the whole drill is slipping here. I don't know if you can see, but see that's one of the teeth of the chuck coming out the back here. I think it's slipping round here. Let me turn it on, watch out for the noise. Yes, that is the torque again. I mean, that has certainly marked this bit of plastic that I'm trying to shred here. Let's have a look. Can I get this off here? Yes. Ah, yeah. So you can see it's took a chunk out of there. See that? Let's have a look. Oh, there is a bit of... Can we see that? Fine. It's quite fine though. So that's a bit of a chunk there. So the basic idea isn't too bad. Let me unplug this before there's any accidents. This is just off an ATX. The 12 volt in this ATX here is blown out. I need to maybe try and sort that out. I tried powering this through this step buck boost converter down here. That's what the electronics is. And it sparked and made smoke off 12 volts. But that's adjusted. But these are really good actually. But sparked and I think it's blown out the 12 volts. So I'm doing this off directly off 5 volts from the ATX. However many amps that is, I think it's 3 amps easy. I'll do this again just to show you, I think. Let's see how it goes. I don't know if there's anything I can do about this. Right, watch out for your ears again. Try doing this back edge here. I think I found out that I didn't have the torque turned fully on there. I see the torque is fully on here. Let's just hang on about a bit.